So we talked about derivatives with respect to tables. AP test loves tables. That's it. So weird. It's going, but it doesn't look like it's going.
Did they get rid of it? Nope. I guess it's moving. I'm not worried about it.
Okay. And then let me give you your table here. You can copy that down while you're copying. T and D of T, that's the national debt, and at the time that it was reported. It's a scary business here. Billions of national debt. Okay, you ready? Okay. All right, so we have this table, and that's all we know. Now, remember, these are ordered pairs. Okay, that's all we have, ordered pairs. Okay, we don't know what 1990 is. We don't know what 1999 is. So we have to just make do with these 4 ordered pairs that we have. Now, if you want, sometimes a sketch is helpful, sometimes it isn't, but let's look at what D prime of 1990 might mean. Okay? Interpret. That means, what in the world does that mean? Interprets. D prime at 1990. So, we know D prime is the rate of change. So what's changing here? What's changing in your debt here? Right, your rate of change of your debts, and what does the 1990 have to do with it? That's when it's happening, that's right. In, maybe I should use it instead of that. That's the interpretation. Anytime they ask you for your interpretation, they're asking you to put it in words or something like that. Okay, so D prime is the rate of change of debts. D prime of 1990 would be in 1990. Good. Okay. Now, we don't have any kind of, if you look, we could say, all right, let's do 1990. I'm not going to spend a lot of time, but this is what you would do. 930.2, 1995, 85. You're about double that. It's a scary thought. 1995, you're double again. And then, you know, not that much more. Okay, so honestly, this is your graph. And you don't really know that it's not dipping, and, you know, you don't really know that it's, you know, maybe doing this. You know, you don't really know. And you can't know with just the 4 ordered pairs. So you have this kind of relationship. It's clearly increasing, right? Because if you, all you're given is these 4 data points, it's bigger than it was the year before, the 5 years before, and so on. So it's clearly increasing. All right, so all we can do is say, all right, where's 1990? 1990, here's 80, here's 85, here's 95. 1990 is somewhere about right here, right? Okay, now, that's the ordered pair D of 1990. It's not D prime. And what does D prime look after? Limit, but what is it? Interpretation geometrically, what is it? Say it again? Okay, no, I'm not hearing all of what you're saying. You're just hearing tangent. I like that word.
Tangent line.
What about the tangent lines? Okay, so technically you are after this tangent line slope. Okay, now there's no way to get that because there's no way to draw the thing. So what we're going to do is we're just going to assume that it's going to be the same as if we were doing a regular slope. Okay, so I got that. Let's, I've really said that, but let me get rid of this. Since the derivative is the limit of the difference quotients, the difference quotient should give a decent numerical when h is sufficiently small. Okay, so d prime of t is going to give me, is going to be allowed to give me this. Okay, I know 1990 is between 85. Honestly, I wouldn't even write that because I don't think it's very meaningful to you, so that's what I write it. D prime, this is how I'm going to find it, because 1995 and 1985, 1990 is between there, this is the same as the as you would find. Yep. The average slope between 1995, 85, and 95. Okay. Oh, sorry. We'll do that. Okay. So, bottom line, if you have table values, you are going to find the derivative, as in the tangent slope. You are going to find it the same as you find the what we call the secant slope from before when using table values. Okay? Because that's all you have to work with. You don't have an equation. Okay? Now, there are better answers than others. Like 1990 is between 2000 and 1985, right? So let's find this value. Did anybody do the math on here?
302.81.
This is 302.81. How do we get 2 decimals? There's only one.
Fair question.
Okay.
Oh, because I divided it by 10. By -10 on the bottom, which we have the decimal place.
Okay. Okay. All right, and then figure out this one. D of 2000 minus the D of 1980. 2000. So let's see. D of 1985. 1980, sorry. I went to 80. All the way to 80. 930. Divided by, how many years is that? 20.
This just stresses me out. I like the math, but like the fact.
Well, okay. So now let's take the average of those two. And the average is 270. So you have a wide range. Which answer do you think is better, the 302 or the 237? 302, because you're closer into the actual, whatever this curve is in between, we don't know. So we're just basically finding the slope of the secant line between those 2 points. Okay? Now, like I started to say, and I didn't finish, the AP loves table values because it is a concept, but it's not real detailed. You can do a simple mathematical thing, so be aware that you are going to see a lot of details or table values. I've got another one in here. Let's look here. Okay, it is again year and N, and I'll explain to you what N is in a minute here. We got 2003, 2004, 2005, 6, and 7. 7225, 8569, 10,241, 12,440, 15,011. Maybe you drink coffee in here? Like this. Okay. N is the number of locations of a popular coffee chain, coffee house chain, okay, in the year. So clearly, what kind of function are we talking about here? Possibly, but I wasn't even going for increasing or decreasing. Definitely increasing, okay? And both of our examples have been, but let's find the average rate of change. Yes. Yes, this is an N. Yes. Not look like an N? I was writing it without. There we go. From 2005 to 2007. Okay, half of y'all do that. So Ellie, Ashley, and Lauren, do that one. And then Catherine and Ellie do from 2005 to 2006. Okay, and I'll do from 2004 to 2005. Everybody know what they're doing? How to find it? Mm-hmm. Yes? Okay. You got an answer? Ellie, you got one?
Mm-hmm.
You're going to the middle one?
Yes.
Okay.
2,199. 2,199.
Okay.
Sorry, words.
You're good. And what about this first one? What'd y'all get?
I got 2,185.
385?
Yes.
Is that what y'all got? Not that I don't trust you, Ellen. Okay, what does that number mean? What do these numbers mean? Okay, this number means different than this number, means different than this number. So, Lauren, tell me what that number means. Okay, tell it in terms of coffee houses.
Okay, it's roughly
So it's the average, it's how much they're changing from 2005 to 2007 on average, okay? So we changed not so much, 2005, look how much we changed. So it's increasing even faster. So, all right, so that's an average. Now let's look at, and notice the word is estimate, because we can only do what we can do. Estimate, this is part B, the instantaneous rate of change in 2005. Okay? Now, we've really done the work. You just have to decide which one do you think is a better estimate. Because the instantaneous is the same as the derivative, so that really we're looking at n prime of 2005. So we could start from 2005 to 2007. Do you think that is the best two data points to use? I don't either. Okay, what about 2005 to 2006? Why not?
I think the 2004 and 2005 one is better because from a later year to a more recent year to 2005.
Okay, so that's a matter of opinion. So you could do any of them, and any of them would be considered correct. Okay, you could take the three and average them. That's ideally, that's what you do, and that's what the book will tell you to do. But the AP people don't expect you to do that 3 times. They say just pick one. I usually like to have, I like to what I call straddle the numbers. So like if 1990 is in between 1995 and 1985, that's the data points I would use. In this case, you know, you already have 2005, so you're going to use either these two or these two. This is too much. That's not best. But they would come out, right? You just got to grab the closest. So now, if we say it's, what is the average? Anybody find the average since we already did the math? 2385 plus 2199 plus 1672. Divide all that by 3. 2085. Now, again, unless you've already done the math, they don't. If this was the only question, please don't expect them. They don't expect you to do that. But let's just say it is. What does that even mean? Instantaneous rate of growth in the coffee houses. What does that mean?
The rate of growth in 2005 is that.
The rate of growth in 2005 is 2,085 coffee houses. Okay? At the moment, whenever they said, okay, it's 2005, let's count our coffee houses, whatever, that was already been determined. So it's an instant or it's over a time frame. This is per year. This is per year. I don't know where I put my numbers here, but all this was per year. Coffee houses per year. Coffee houses per year. Yada, yada, yada. And so it's instantaneous, too. But just, again, the point is that we do have, you know, you can decide what you're going to use. All right, so we have a review. Hold on, let me find mine. Who can tell me the definition of a limit right now? Definition of a limit. Can't answer.
The limit of f of x is x approaches a.
Hold on, you're reading to me. You don't know it?
Well, there's that, but like, is that what you want?
That's what we're
They're like, you all use the word in the definition, so I didn't know if you wanted us to say
Yeah.
limit of something.
The limit of X per A.
Where the things meet. Oh my God, everyone in the class.
All right.
The limit of X per A.
So the limit of f of x equals,
Capital L.
that's the definition?
That's like a formula. That's
You're too hard for me.
It's the time.
What do we have to know here?
Oh, where's it from the left and the right?
Hey, there we go.
Good job.
Actually, you can shorten it up and just do this. Okay. Okay. So that's your definition of your limits. What about, we know the limit laws, right? Limit of the sum is some of the limits, all those, okay? And the only time you need those is when you're doing graphs or when you're doing tables. You don't need to do, spread it all out like we did. That's wasting your time. That's called direct substitution. No, I'll just say find the, no, I'm not going to tell you use your limit laws or not. Okay, what about the IVT? I know it starts out with, I'll start you out. If f of x is continuous on the interval a, b. What's the rest of it? No, we're not necessarily always talking about roots.
Trying to put it into words.
There exists, no, not
Just a root.
a c in the interval a, b such that, there you go. And you can, go the other direction too, but I'm not going to write it. You all need to have that down in words. I know that's memorizing, but remember that's the first step in applying is knowing what you're applying. Okay? Sometimes it's a root. Sometimes f of c equals 0, but that is a special version of the IVT. That is not always the IVT. Okay? Next on my list is definition of continuity. Come on, I know this. Continuity. Whoops. Okay, what's continuity? Can I tell you there's 3 pieces? Would that help? Is continuous at a if and only if. One. F of A exists. There you go. Limit as we approach what? Okay. All right, there you go. Now, when you're showing that something is continuous, don't use the generic A. If you're trying to say it's continuous at 2, use 2. Okay? Be as specific as you can, even though you're applying the definition. Okay? So that's continuity. Then we have limits involving infinity. Remember, that's where the vertical asymptotes and the horizontal asymptotes come from. So who can tell me how do we get a vertical asymptote? X equals A is a vertical asymptote if what? What are we doing when we get vertical asymptotes? It's theory. It's not words anymore.
They just need to limit of A as X percent to the left doesn't equal limit as X percent.
That's vertical asymptote. You go both directions. You can say, oh, I have this, so that means this, or I have this, so that means this. Okay, and don't forget about your vertical asymptotes from pre-cal. Now you know about those, okay? And this is supposed to be an equal sign. I don't know if you're telling me, but. All right. So if you're a card person, these are all your cards. All right, what about horizontal asymptote? You know that one?
That would be an equation where the limit approaches infinity, and if you're going to have to look at the degrees,
And it could be plus or minus, right?
yeah, plus or minus. And then if the degrees are the same.
Okay. But you're getting into all that. But that's the definition. You're going to, but yeah. And then we have 3 on rational equations, rational functions. All right. The degrees are the same. Go ahead, Ellie.
Then it's going to equal the coefficient.
Ratio of the leading coefficients.
And then.
And by leading, we don't mean the first ones, we mean the biggest. Okay, good. What are you doing? Sorry. What am I doing here? Go away. All
And
right.
if the degree on the bottom is bigger than the degree on the top, then it's going to be 0.
So y equals 0. That's the limit. Okay.
The numerator is bigger than the denominator. It's normally,
What does that mean?
it's like the
Right. So what's the limit?
There's one huge.
The limit would be this or this. I know we got off of horizontal asymptote, but as long as we were going there.
Wait, so you just write limit.
Well, I mean, depending on what you're answering, you wouldn't have you probably, if this is, I mean, it just depends on what you're asking. If you're not asking for a horizontal asymptote, you're done there. You don't have a horizontal asymptote, but you might be using the horizontal asymptote to get me a limit.
Is that the thing with the
Yes. Yes. Okay. What's next? Definition of derivative when you know the value of A, when you don't. I could not get that space to go away. I tried. Definition of derivative when you know the value of A. What is it? F prime of X equals what? What? Limits? That's not the one I was.
Oh, yeah.
And then after the 1% of the.
Okay, very good. And the other one, when you don't know A,
Oh, it's the limit at h equals 0. F of a plus h minus f of a. And then x. Wait, h. Yeah, just h.
okay, and she used A, I used A. Same difference. You can use A or X. It depends on whatever they're asking for, honestly. Okay, so those are your things that you need to know. Pretty solid. All right, how to calculate the limit of a function using substitution, graphing, tables, and or algebra. Okay. Oh, wow. And I got some problems here, I don't know.
We'll get into those. I'm not gonna record them though. Where'd it go? Here we go. Maybe. Ah, what happened to my? All right, ladies, focus.
All right. So those are all those limit problems. Average rate of change, we just did a couple. Average rate of change is the same as, what do we call it? The regular slope formula. Okay? Slope of the curve of a point is the same as tangent to the curve of a point at a point, which is the same as a derivative. I'm going to ask you different ways to find the same thing. Equations of tangent lines, derivative of function using definition. So this 12, 9, and 10 are all the same thing, right? And then using values in a table is that last thing we just talked about. Okay? Again, there'll be two parts, non-calculator and calculator, multiple choice and free response. For multiple choice, we'll have 5 choices because those will be AP problems. And the other ones will be, you know, received credit, partial credit as needed. Okay. Is there